I would like to start from the words, what is a great day today? Because today we have two important events. On this day, exactly 10 years ago, the rector of Taras Shevchenko Kyiv National University signed an order of the establishment of the Faculty of Information Technologies. And today, the International Scientific and Practical Conference, Information Technologies and Implementations, begins its work. This is already the 10th international conference organized by the Faculty of International Technologies together with the Faculty of Computer Science and Cybernetics of Taras Shevchenko Kyiv National University. Moreover, by the way, the conference is being organized for the fourth time by the joint efforts of scientists from these two faculties. During 2 days, scientists from various higher educational institutions and research institutions, representatives of various countries will give report on their latest achievements in the field of information technologies. This forum meets annually. The number of conference participants is increasing and the quality of the reports is improving. Confirmation of the high quality of scientific reports last year was the placement of 6 volumes of IT&A 2020, IT&A 2021, and IT&A 2022 conferences in the International Open Access Archive of CEUR and their indexing in the Scopus scientific database. Among the organizers of the conference, Kyiv National University, National Technical University of Ukraine, KPI, Glushkov Institute of Cybernetics of the National Academy of Science of Ukraine, Institute of Information Technologies and Teaching Aids of the National Academy of Science of Ukraine, Institute of Information Registration Problems of the National Academy of Science of Ukraine, Institute of Software Systems of the National Academy of Science of Ukraine, Council of Young Scientists of the Faculty of Computer Science and Cybernetics, and the Faculty of Information Technologies of Taras Shevchenko Kyiv National University. Public Organization Cognitive Research. The program committee of the symposium includes famous scientists from Ukraine, Australia, Austria, France, Japan, Germany, Hungary, Great Britain. About 150 scientists' reports in English were submitted for participation in the conference, the author of which are about 300 scientists. Among the authors of the materials presented this year at the 10th International Scientific and Practical Conference, Information Technology and Implementation, in addition to the report of Ukrainian scientists, there are reports of scientists from the USA, Great Britain, Italy, Poland, Czech Republic, Finland, Lithuania, Slovenia, Slovakia, Kazakhstan. I wish the participants of the international conference fruitful work. I hope that this forum will continue in the future and become even more popular among scientists from different countries in IT area. Thank you for your attention.
Dear Volodymyr Vasilievich, thank you for warm words to participants of conference. Dear colleagues, for the first time, we are holding a conference together with our good friends, colleagues from the Faculty of Computer Science and Cybernetics of Taras Shevchenko National University of Kyiv. We thank them for their cooperation, reviewing articles and helping with the organization. The welcome address is given to Dean of the Faculty of Computer Science and Cybernetics, corresponding member of the National Academy of Sciences of Ukraine, Doctor of Physical and Mathematical Sciences, Professor Anatoly Anisimov. I would like to ask Anatoly Vasilyevich to speak.
Thank you very much. My task is much easier now after the words of the first Vice Rector of our university. I will join to welcome words of the first Vice Rector of our university. This is a great honor to welcome all of you at the 10th Conference Information Technology and Implementations. The conference is conducted for 10 years. Each year brings new participants to the conference, and the number is sustainably increasing. Analysis of accepted papers shows that the high quality of presented works. As we know, the technology, information technologies play very important role in society, and this is the base for future high-tech technologies in other fields. So this is very important conference. And this 10th conference is of special significance. It is dedicated to the 10th University of the Faculty of Information Technologies. On behalf of our friendly faculty, Faculty of Computer Science and Cybernetics, please accept my greetings. And so I wish you fruitful and successful discussions and new scientific achievements. Thank you very much. And
thank you, dear Anatoly Vasilyevich, for your kind words and cooperation. Many thanks to you and your faculty for congratulations to our 10th anniversary. A lot of popularization work was done by our program committee members. I would like to invite to welcome speech the member of the program committee of the conference, the corresponding member of the National Academy of Science, Professor Yuri Krak. I'm asking Yuri Vasilyevich to speak.
Thank you very much. Dear co-chairs of International Conference, Information Technology and Implementation, dedicated to 10th anniversary of Faculty Information Technology, dear colleagues, friends, ladies and gentlemen. I congratulate all employers, professors, and students of the faculty on this great date for faculty and our university. I wish everyone a new achievement in education and scientific research, and have a good student. Good student is very important. I would like to note that I am pleasured that I was a member of a small team for organization of the Faculty of Information Technology 10 years ago. And my mind, recommendation and advice on the future of the Information Technology faculty were supported. But the proposal to organize a Department of Artificial Intelligence, which was important for me, was not supported. To the participant of the conference, I wish that in your presentation of the new results will be heated discussion. You will gain new impression and experience, and you will find new colleague for joint research and cooperation. I also wish everyone good health and our victory in the war. Thank you very much. Good luck.
Thank you very much, dear Professor Krak. Foreign members of the program committee provided significant assistance in creating our conference and bringing it to serious scientific level. We invited Professor Frédéric Mallet from France to give a welcome speech. But Professor Mallet is in Korea, and today he is absent. Dear colleagues, turn on the cameras. Let's take a photo. Take on the cameras, please. first screen, second screen, third screen, and first screen. Thank you. Dear colleagues, today we are working in difficult conditions, in conditions of Russian aggression against Ukraine. Today we, scientists and teachers, are on the second and possibly the third line of defense, educating students who will rebuild our country, conducting research, the results of which will be used for the benefit of Ukraine. We aim to do our job. Today, the Faculty of Information Technology is celebrating its 10th anniversary. Its creation, formation, and development took place in difficult conditions of Russian aggression and the coronavirus. But the team of our faculty coped with all the challenges, and today it is a powerful, until with about 1,900 students and more than 100 teachers. We are moving forward, we are bringing the future closer. Thanks to our team, thanks to our faculty. Dear colleagues, everyone received the conference program by email. We will start working. I wish all participants of the conference health, success in scientific work, victory and peace. Many thanks to the Armed Forces of Ukraine for the opportunity to hold this conference. Good luck to everyone. We are starting the plenary session, and the first report is according to our program. Artem Hovrat, Volodymyr Kobzev, Sergei Yakovlev, using parallelized neural networks to detect falsified audio information in socially oriented systems. Please, dear colleagues, 20 minutes, your time.
Can you hear me?
Yes, of course.
Good. So, good morning, dear audience. My name is Artem Hovrat, and now I want to present the results of an investigation conducted jointly by the Kharkiv National University of Radio Electronics and the Lodz University of Technology, using parallelized neural networks to detect falsified audio information in socially oriented systems. In recent decades, technologies capable of falsifying information have reached the level where the need to detect forgeries in social-oriented systems, for example, social networks or news engines, is being discussed not only at scientific level, but the situation is different depending on the nature of the data. In particular, in the case of video information, the distortion has not yet reached the required level. In the case of the text, there are a large number of international studies, but audio falsification has recently been able to go beyond simple identification, so this determines the severity of the issue. In normal conditions, the problem can give rise to local conflicts in a group of people. This is especially noticeable in social networks. This situation becomes more acute in condition of military and political instability, when any information is perceived through the prism of intensified emotions, which slow down the process of critical thinking. In the case when fakes are part of the news information field, they can accelerate social shifts and unrest caused by the crisis and thus intensified consequences. It can be economic, purely social, or even military in nature. As an example of a similar situation, we can mention fake audio related to the COVID-19 pandemic, or a huge number of falsified recordings at the beginning of the invasion of the Russian Federation into the territory of the Ukraine. To solve this problem was decided to find a method that allows us to effectively recognize the fact of forgery of an audio messages. Following this motivation and after conducting a preliminary analysis, it was decided to concentrate on neural networks with elements of convolutional and recurrent architectures. The purpose of the current research is to develop an effective model for determining the fact of falsification of audio data and use parallelization technologies for speed-up neural networks. To achieve this goal, it's necessary to determine the features of audio in social-oriented systems and define the pre-processing algorithms for it, analyze the international experience to create the several models for detecting effective falsification and the approach to speeding up it, and conduct an experiment to find the most effective model. So let's look at each of these points one by one. But first off should be mentioned the similar investigation related to the current topic. As you can see on the slide, the problem of data falsification is being considered quite actively on different levels, which contributes to the development of this scientific area. After considering these sources, several bases of falsification can be formed: synthetic creation of audio with the help of artificial intelligence, composition of existing soundtracks to distort the essence of the original information, and contextual distortion. The first two cases will be considered later when processing audio as a signal, and the last one is when processing audio as text. It also worth mentioning several features of falsified audio data that distinguish it from simple text information, and two ORAL's limitation which should be accounted. The first feature is that a large number of rhetorical questions with a condemnatory meaning. The second one, absence of negative construction to reduce cognitive load, and the last one, using appeals and incitements in appropriate contexts. The first oral limitation that some features may not manifest themselves, and the second one, that incorrect audio recognition or pronunciation feature can be important for our process to conversion of audio into text form. Yeah. So the latter one, oral limitation, necessitates the use of highly efficient conversion method. Therefore, it was decided to use Google Speech-to-Text API, but the accuracy of this method is not equal to 100%. It's connected with two groups of audio features which describe on the slide and naming speech-to-text and special issues. After conversion our audio into text, we should translate it into readable form for our algorithms. Tokenize text cleans, stems, and lemmatize to find the BM25 characteristic and polarity of words defined by the special libraries of Python languages to generate the main characteristics of our audio as a text. We should also add the external characteristic defined by 50 main news related to the topic of our audio, message weight, and degree of reliability of our conversion process to generate the aggregation result as our input for our neural networks. In the case of preprocessing audio as signal, was decided to split the record into 200 millisecond window. This size is based on the Gaussian distribution and the Mahalanobis distance. This is explained by the fact that in case of 200 millisecond window, the probability of centered value hitting 3 sigma in 99.7%. This allows us to effectively separate the localized data region from noise and silence, and after this separation process, the important data should be converted into Python-readable form for processing by neural networks. It can be also augmented with vector after regression algorithms. As mentioned earlier, it was decided to use architectures based on recurrent and convolutional neural networks. One of the simplest of them, and at the same time one that takes into account the context in full scale, is LSTM, recurrent neural networks with long-term memory. Simplified scheme shown left on the screen. It also makes it clear that context only counts in one direction, whereas for the Ukrainian languages, it's typical to define the context in two directions. That is why it was decided to also consider the bidirectional LSTM. Its scheme is shown on the right. The next simple neural network is convolutional network. What is important to mention are the results of cross-validation, in particular the obtained values of hyperparameters. For example, depth, which equal to the number of features using the convolution equal to 5, stride equal to 1, patterning biases was decided not to use since it could cause the context to be, and kernel size equal to 4. What is more important is that it was decided to use these neural networks in a more complex architecture, which you see on the slide. In the future, we will call it RCNN model. As you can see on the screen, after dividing the data into frames, they are separately processed by convolutional neural networks. This reduces the dimensionality of the data and simplifies the identification process of further dependencies. Don't forget that the convolutional networks allow us to take context into account in several directions. After this stage, the data is transferred to the bidirectional and LSTM, and after processing by these networks, the result is aggregated and the necessary set of coefficients can be formed. This combination of model can provide superior accuracy, but it also takes training and execution time. To reduce the influence of this factor, it was decided to use parallelization tools, in particular MapReduce technology. Based on our previous research, also this approach is complex in configuration, but it allows us to get it much faster and it's easier to support. Since the volumes of data are significant, it was also decided to store them in non-relational databases, and to speed up interaction with them, the Hadoop version of MapReduce was chosen. In this version, we have not only map and reduce function, we also have a partition and combine function, which are similar to map and reduce, but in terms of one node, not in all network. And also we have a sort function before reduce. That's a very important thing when we talk about technical implementation. Let's move on to the formation of experimental environment. At the beginning, it should be noted that a target data set, it was decided to use audio with altered news related to the full-scale invasion of the Russian Federation into the territory of the Ukraine and the 2019 election process in the Ukraine. After conducting an expert assessment among 30 reviewers, it was found that the most important indicators are accuracy, determined by the combination of F1 score and precision normalized between 0 and 1, with importance coefficient equal to 16, time saving of model training for same capacities for 2 types of audio analysis process with importance coefficient equal to 2, and minimum permissible amount of data volume to achieve accuracy equal to 90%, with importance coefficient also equal to 2. And also the possibility of taking into account the context determined by special rules with importance coefficient equal to 10. But I also mentioned that the last one, features context, will be ignored for data as a signal. The next stage was the implementation of the above algorithms. As can be seen on the slide, to ensure the highest quality processing of audio as text, it was decided to use a set of models of NLTK framework as well as number of Python 3 libraries. You can see also the example of function for processing, for preprocessing our audio as text. In the case of the MapReduce technologies, it should be noted that it was used to speed up vector after regression when augmenting audio as a signal. An example of mapping function pseudocode is shown on the screen on the left. In the case of neural networks, it was decided to carry out special parallelization only for BLSTM and RCNN architectures. For bidirectional recurrent neural network with long-term memory was separated into 2 directional and independent nodes. This will give a 2x speed up. In the case of RCNN, each individual convolutional neural networks will work on a separate node, after which the data is aggregated and transferred to a parallel version of BLSTM. The reduce function for CNN you can see on the slide, also in pseudocode form. Having considered all the main features of the design of the experiment and its implementation, let's move on to its results. As you can see on the slide, for audio as a signal, the most efficient in terms of time saving model, is CNN model. In terms of accuracy and volume saving, it is RCNN. But the most efficient in general, we can see this a little later. For audio as text, we receive the similar results. The most efficient in terms of time saving is CNN. In terms of accuracy, volume saving, and context is RCNN. But also in terms of accuracy and context is BLSTM. So after processing the above results and calculating the values of linear additive convolution with weighting coefficients defined via importance coefficient, the following was established. For audio as a signal, the most effective model is BLSTM. However, when parallelized with MapReduce technologies, a similar efficiency result is obtained by RCNN architecture. For audio as text, we receive the similar result. When we speak about MapReduce, in the case of BLSTM, the acceleration equal to 2, and in the case of RCNN, it's about 3.5 or 4.3 at the maximum for 3 and 4 nodes respectively. So the current work aimed to develop an effective model for determining the effect of falsification of audio data using MapReduce technology. Based on the review of the analyzed studies, it was decided to focus on CNN, RNN, LSTM, BLSTM, and RCNN models. In the course of the experiments, it was found that the BLSTM is the most effective, but also it loses in speed to less complex model. It's found that the gain of reprocessing time saving when using MapReduce technology can reach 4.3 in the case of text and 4 in the case of signal. At the same time, several important questions remain open related to the peculiarities of audio processing, both in text form and in the form of the signal. This allows us to continue the process of investigation in this area. So thank you for your attention.
Thank you. Wonderful results. Maybe, dear colleagues, have any questions? I have one question. Can you formulate the main proposition of your research?
The main proposition to create the RCNN implementation with better parallelization technology of MapReduce with more than 4 nodes to increase the speed of processing and training time. And this can be implemented as a part of, for example, social networks and so on, to reduce the problem of fake audio into these social networks, or, for example, news engine.
Thank you. Any questions, colleagues?
May I ask one more question?
Please.
Alexey Aletsky, National University of Kyiv-Mohyla Academy. You mentioned LSTM as a very popular type of recurrent neural networks. But did you think about transformers or BERT?
Yeah, we think it in our research, but we concentrate only on these 5 type of neural networks, and that's all. I think that this type of networks can be used in our next researches.
Thank you.
Thank you very much. Any questions? Thank you, dear Tom. It's all.
Thank you.
Next presentation, Tatiana Sergeyeva, Sergey Bronin, Tadej Glazar, Technology for Synergetic Solutions, Co-creation based on multi-agents, diversities, interaction. Please, dear colleagues. Don't see. Yeah, okay.
Yes. Thank you. Do you hear me?
Yes, of course.
Thank you. Now I'll start. Oh, sorry. We propose to your attention technology for synergetic solutions, co-creation based on multi-agents diversities interaction that was made by Tatiana Sergeyeva, Sergey Bronin, and Tadej Glazar, professors of Kharkiv Polytechnics, Taras Shevchenko, Ukraine, and Ljubljana University, Slovenia. Increasingly, when developing smart technology or devices in manufacturing, retail, healthcare, business, or everyday life, be it a smart home or Internet of Things, this is a need to provide constructive feedback from users. Traditionally, living laboratory technology is used for this purpose. Unfortunately, for all their advantages, laboratories were unable to ensure true co-creation of synergetic solutions by multi-agents. An analysis of research in the target area shows that while the importance of co-creativity is recognized, there are practically no developments built on truly scientifically based principle of organizing multi-agent synergetic interaction. It is believed that this is explained by the complexity of multi-actor sector disciplinary interaction, which requires an understanding of its system-forming factor, content structure, pattern, and mechanisms. There is also a fundamental reason associated with a change in the scientific paradigm, the reorientation of target science to impact-orientated with the introduction of human-centered criteria of social, moral, economic, and environmental safety. This paradigm changes the entry point into the problem of multi-agents interaction, since each agent is considered as a holistic person and not just the owner of a set of professional qualities and competencies. This in turn changes the strategy, methodology, and technology of co-creation. Multi-agent interaction aimed at co-creation of synergetic solutions becomes the driving force for co-development, which in turn requires an understanding of its nature, patterns, and mechanism. In order to model, simulate, pilot, control, measure, duplicate, disseminate, and sustainably develop the process of co-creation, it is necessary to identify the system-forming factor, structure content pattern that is meaningful structure and structured content and mechanism. The structure content pattern of multi-actor sector disciplinary co-creation includes activity, it's A, co-creation of innovative synergetic solutions, actors as agents of a multi-actor sector disciplinary alliance, including researchers, developers, designers, practitioners, users, and stakeholders. Object of activity, O, multi-agent synergetic solutions, and conditions of activity, C, the possibility of making multi-agent synergetic solutions depending on actual state, functions, situations, and circumstances of the environment that simultaneously is developing and developed. The ecohumanistic model allows simulating the existential process of multi-agent synergetic interaction in order to develop an efficient digital support system at each scientifically based stage of multi-actor sector disciplinary solutions co-creation. There are the following stages: strategic sense cognitive orientation of agents in a target area or product, developing an ideal and real synergetic profile of multi-agent solutions, mapping multi-agent synergetic solutions to an interactive map of the current state and changes development of the target area or product, multi-scale measurement of solutions' potential efficiency, planning the implementation of solutions with the definition of specific deadlines and performances, piloting and creating patterns of multi-agent synergetic solution, efficiency assessment, adjustment, and creation of demonstrations or lighthouses of solutions in the target area product. The set of digitized tools includes the interactive database, the so-called Omnibase, which self-develops in the process of multi-agent interaction, technology for overlaying profile of multi-agent solutions, an interactive map of the current state and changes in the target area product based on adopted solutions, interactive continuum of solutions implementation, an interactive multi-scale system for measuring the efficiency of multi-agent synergetic solutions, technology for piloting and creating demonstrators of solutions for specific target area or products, and technology for creating the so-called atlas of interactive maps, reflecting dynamics of target area or products development as sustainable developmental lighthouse. The biggest problem of multi-actor sector disciplinary interaction is the time-consuming and labor-intensive search for a common language, which is explained by multi-agents' cognitive schemes diversities, both in content and level of development. Ecohumanistic technology allows providing efficient synergetic interaction of multi-agents via development of their cognitive schemes, which determine the development of neural network objects and links in the process of solution co-creation. Such science-based development is supported by a digital tool that sets a strategic sense cognitive orientation for the ecohumanistic development of solutions. Omnibase represent an interactive cognitive resource for orientation in the target area or product based on a generalization of socially developed experience. It includes, first, a search system for solutions that provides information upon request in the format of the structure of the co-creation process, object of co-creation solutions in correlations with their potential efficiency, objects and agents, multi-agent subject of co-creation, this is experts, practitioners, stakeholders related to the target area of human resources, and conditions of activity specified by type, function, and circumstances. And the second is a compendium of information relevant to the target field or product represented in various formats: text, graphics, audio, video, in the form of articles, reports, case studies, interviews, precedents relevant to the field and structured according to the logic of such criteria. Co-creation involves true inclusivity rather than formal and passive participation in making discussion or surveys. Such co-creation is possible only on the basis of the motivated activity of all agents. The gradual development of such motivation is ensured with the framework of scientifically based eco-humanistic technology through the integrations of sense cognitive orientation into agents' sense cognitive scheme, which is reflected in the development of objects and links of agents' neural network. Such an initial strategic orientation determines the involvement of the agents, which determines the efficiency of solutions and personal development as a co-creator, followed by self-identification with the decision made. The technology of engagement involves the following stages. First stage is constructing an ideal profile of the target area or product, providing cognitive and sense orientation as well as involving personally in the process of co-creation and self-identification, which fuels personal motivation throughout the process of making and implementing the solutions. The second is constructing a real profile for making a realistic decision based on detailed familiarization with the condition of given object. As a result of development of critical thinking of multi-agents occurs, which in turn develops both cognitive and sense resources that determine the quality of the solutions themselves. And the third is transforming ideal profile and real profile into a synergetic profile based on original technology of superimposing sense cognitive structures, which allows solving one of the most difficult problems arising in collective decision: the systematic integration of diverse solutions into a holistic, synergetic solution without losing the uniqueness of individual solutions. Profile reflects graphically an individual vision of multi-agents, ideal solutions obtained by selecting solutions directed from the basic omni-based metrics through a query of the search engine ideal profile. An individual vision of multi-agents real solutions obtained by identifying the lines remaining in the matrix after removing decisions that are irrelevant to the unidentified developmental zone real profile. And integrated vision of multi-agent solutions obtained by superimposing individual and real profile, synergetic profile to identify the congruence as the basis for making a synergetic solution, diversity as the basis for discussion, and gaps as the basis for co-creation of a synergetic solution. Multi-dimension in characteristic of existential holistic process determining the range of selection and evaluation criteria for omni-based search system, as well as for evaluating multi-agent synergetic solution. The evaluated profile reflects the expert's vision of the efficiency, relevance, and performance of solutions through multi-scale measurement with appropriate tools including multi-scale filter, an original tool based on the profile overlay technique, allowing multi-scale measurement of multi-agent solutions' impact, efficiency, weight, and performance. And motivation matrix, an original tool based on a technique of superimposing profiles reflecting the hierarchy of human needs, existential, survival, quality, and sense of life. It is also measured the efficiency of solving problems based on formula that includes the parameters of accuracy, speed, and completeness. The complexity of sense cognitive schema based on the profile overlay technique, professional, social, and existential senses, as well as meta abilities, including meta qualities, proactivity, autonomy, objectivity, responsibility, flexibility, creativity, and empathy based on a regional questionnaire. The obtained data are processed by statistical methods, including correlation and factor analysis, which determines relationships indicating possible causes verified during the scientific developmental experiment. The evaluated synergetic profile of the multi-agent synergetic solutions is transformed into the continuum of sequential tasks, an interactive e-tool for action planning in the format of visualizing the timetable of the process of implementing selected solutions and setting tasks and distributing responsibilities between agents. The continuum organizes in a system the process and activities of co-creation, universal in format and unique in content. Continuum reflects the specifics of implementing solutions under existing conditions and available resources. A set of tools for disseminating results includes their demonstration and multiplication. The demonstration is carried out by creating an atlas of interactive maps reflecting dynamics of target area products co-creation as sustainable developmental lighthouse. It is proposed scientifically grounded and experimentally tested innovative technology for multi-agent co-creation of synergetic solutions. The technology is based on an eco-humanistic model of multi-agents interaction, which uses diversity as a driving force. Defining a system forming factor, a structure, content, pattern, and the mechanism of interaction allow managing, simulating, piloting, measuring, multiplying, disseminating, and ensuring the sustainability of the co-creation process. The proposed innovative model of synergetic solutions co-creation without loss of multi-agent diversity is supported by a system of digital technologies and tools developed in strict accordance with scientifically based stages of development and decision-making. The stages includes creation of a strategic sense cognitive orientation of multi-agent in the target area or product, personal involvement of multi-agents in co-creation process, specification of multi-agents' understanding of changes causing transformation of a real product based on their solutions, multi-scale measurement of potential efficiency, planning, implementation, piloting, and creating patterns of multi-agent synergetic solutions, and creation of demonstrator or lighthouse of a multi-agent synergetic solution in a target area. A digitized technology or tool has been developed to support each stage of multi-agent synergetic solutions, including the interactive Omnibase, which self-develops in the process of multi-agent interaction, technology for overlaying profile of multi-agent solutions, an interactive map of the current state and changes in the target area based on multi-agent synergetic solutions, an interactive continuum of multi-agent synergetic solutions implementation, an interactive multi-scale system for measuring the efficiency of multi-agent synergetic solution, technology for piloting and creating demonstrators of multi-agent synergetic solutions for specific agent areas of product, and technology for creating an atlas of interactive maps reflecting dynamics of the target area development as a sustainable developmental lighthouse. In perspective, the eco-humanistic model can be used for providing synergetic interaction of human and artificial intelligence agents to prevent risk of confronting arising due to intensive uncontrolled development of artificial intelligence. Thank you for your attention.
Thank you. Dear colleagues, ask your questions. My traditional question, what is your main proposition of your research?
The main proposition was expressed in the very beginning. There is no technology that provides really synergetic interaction, multi-agent synergetic interaction. And as to the future, I think it Our perspective is in interacting artificial and human intelligence, and we should understand all these mechanisms, all these co-creation process. That's why I think that it has a good perspective for in practical, as a practical task.
Maybe can you predict the result of your proposition? Maybe
The
you have
result-
this.
Yeah, we have our group, our research group worked on this proposition within the Horizon, Europe Horizon project. There are some direction within the new paradigm, scientific paradigm that is impact orientated and human centered. And we try to make this work really multidisciplinary. I think that we lack this multidisciplinary interaction in providing really practical and impact-oriented solutions. That's why I think that we can start from organizing efficient teams that know how to act and have concrete methodology and technology with the support of digitized instruments. It's like a beginning. And as to the perspective, I think that they're quite broad.
Okay, I explain my question. Our conference has two directions, computer science and information systems. And usually we have quantitative results of our research, but we can see in this research these results, quantitative.
There are quantitative results because we made experiment, we measured as multi-scale measurement of this process, and we developed all these results. But I thought that it is more important to underline the direction in which we should move, because sometimes we look at it too narrow, because even all these calculations should calculate some content things, some things that are really needed. And that's why we concentrated just on this part of investigation, but we have quite on a scientific basis calculated the results. Next conference, I think that will demonstrate it, because it's impossible to make everything in one report.
We wish you scientific success. Okay.
Thank you very much.
Dear colleagues, maybe any questions? No, thank you. Next presentation, Mykola Kikhtev, Taras Lendiel, Larisa Nikiforova, Pavel Mazurchuk, Marina Lendiel. Wireless subsystem for control technological parameters of electrophysical influence to increase plant productivity. Please.
Good day. One moment, please. You see my presentation?
Yes.
Yes.
Thank you. Okay, my report to a wireless subsystem for control technological parameters of electricity influence to increase plant production. Due to the growing demand for agricultural products, there is a need to intensity the process of growing plants and reduce their disease. Therefore, the technical implementation of methods for altering the functional activity of plants using magnetic radiation at different states of organizing and their automation is an urgent task. The research aims to increase the efficiency of plant cultivation by studying physical methods of controlling their productivity and primarily a computer-integrated system. To achieve this mathematical corrective model of the interaction of laser radiation with solid visual input algorithm for measurement and generation control effects, method of automatic control theory and visual programming in Arduino hardware consist there. The structure of foundation model of the plant biosystem you can see in this slide with example to temperature and humidity of outdoor air and plant and make plant. The calculation of transmission distance to automatic control microclimate control complex, measuring temperature and humidity. You could see some distance between the research transmitter and receiver in this slide. Carried out and the you see this formula. Oh, okay. Experiment computation scheme. You see this slide. The 0.1 plant, 0.2 transference plate, mirror, aperture, polarizing filter, source of location radiation, Faraday cage, recording device, multiple plate, measuring codecs, source of nonlinear radiation. Some mnemonic diagram of technical parameters modern subsystem you see in this slide as monitoring subsystem consists in the transmitter and the receiver, microcontroller to Arduino Nano and RF3 transmitter. Model consists temperature and humidity air. Fragment of program text, there is Arduino ID environment you see in this slide. The program is transmitter and program receiver. Our monitoring complex. Algorithm to remote temperature measurement and control to relay turning off and turning on in this slide. Some laboratory tests you see in this slide, and you and I some video in this slide. You can see one. Okay, you see receiver and transmitter model A, model B, and transmit data, measurement temperature and humidity. It is a laboratory test. The first instance we mentioned, to this project is possible in following areas. Some difficult and creation of distributed database of compound feed receipt and this transfer to the cloud. Consultants, the functionality of the developed subsystem allows measuring the special parameters in the greenhouse and places where seedlings are prepared for plant seeds in the future with the help of Internet of Things technology. The information will be transmitted to a structured server for the operators and analysis of the production process. The software and hardware of the plant's productivity measurement subsystem using electrical influence, which provided for wireless and data transmission, has been developed. The free space station and data transmission range were 46 meters. Testing was carried out in laboratory conditions. Thank you for your attention. Thank you.
Thank you very much. A very short presentation. I don't understand. I see engineering solution, but maybe you can explain your theoretical results, if you have not this result.
It is a testing result in laboratory test our measurement complex. It was will be tested in the greenhouse future.
Dear colleagues, have you any questions? No? Thank you. Next presentation. Alexander Toroshenko, Yuri Shiblanin, Andrei Fesenko, Mykola Pirog, Inna Michalchuk. Ensuring the availability of information resources through the use of an intelligent communication network with the drift of parameters of autonomous segments. Please, the authors.
Moment, please. Is the presentation started already?
Yes, please.
So I can start. Good day, dear colleagues. To your attention, let me present our paperwork, our article about the ensuring the availability of information resources through the use of an intelligent communication network with the drift of parameters of autonomous segments. The importance of availability of information resources in the modern world cannot be overstated. Today, information has become a pivotal resource that defines the development of society, business, science, and culture. So the the availability of information resources holds immense significance for several reasons. First of all, technological advancements. Thanks to technological progress, access to information has become rapid and continuous. The efficiency of business processes, scientific research, medical diagnostics, and more depend on this accessibility. Second one is security recovery. Ensuring availability is part of a comprehensive strategy for information security. It includes measures to prevent data loss, ensure backup systems, and recover data in case of disasters of cyber attacks, which is very actual in our conditions attached to war. Innovation and development, its swift access to up-to-date data and knowledge is the key to innovation and progress. So companies with access to cutting-edge information can adapt and evolve faster than others due to availability. So the next one is data accessibility. So availability guarantees access to crucial data and information required for various purposes such as researchers, analysis, innovation, and problem solving. So ensuring the availability of information resources is important and necessary to achieving success and stability in all aspects of modern life. The purpose of the article is the analysis of the features of functioning and the development of a mathematical model of the system for ensuring the availability of information resources due to the use of an intelligent communication network with random delays of signaling and controlling information. So the control system must ensure the variability of network with a large amount of network equipment as a complex system in conditions of malfunctions and failures in the equipment or uncontrolled changes in operating modes, drift of network equipment parameters and its autonomous segments, disturbed actions, interference, and other device factors. So the modern intelligent electronic communication networks are characterized by a large number of various equipment from various manufacturers and wide range of service provided, the number of which is constantly growing. So the idea of intelligent network is to separate the functions of support, development, and testing of new electronic communication services from the main functions or of the switching node. So service delivery functions are migrating to switch independent computing platforms. It should be noted that here the intelligent network in its meaning and task has nothing to do with the system of so-called artificial intelligence. Intelligent network.
Sorry, this is just your first slide.
I'm sorry. No, I'm changing slides.
No, we see only first slide.
We can see first slide all time.
I see, and how to change.
Maybe reboot the
view.
presentation.
Is it now changing?
No.
No, maybe you should reshare your screen because you share PowerPoint, not just presentation. Not in presenting mode. Now okay.
It's okay, yeah, already?
Yes.
Now it's changing?
Yes.
Yes.
Thank you very much. Where were I? Perhaps already the next one, yes. So it's have nothing to do with the system of the so-called artificial intelligence. So intelligent network management tools with a wide range of such services have their own specifics and are complex systems with incomplete information about the state and parameters of the network as a whole and its autonomous segments. The problem of managing an intelligent network with a wide range of such services have their specifics. Thus, the management tools of an intelligent electronic communication network are a complex system with incomplete information about the state and parameters of the network as a whole and its autonomous segments. The problem of estimating the parameters and the state of dynamic system with a delay based on differential difference equations is considered. So it's shown that delay of the argument, even for a simple differential equation of the first order with constant coefficients, leads to the appreciation of an after effect, which formally corresponds to an arbitrary variations of the order of equation. Such differential equations are called equation with a deviating argument. The results of a numerical analysis based on the digital modeling of the control system of the parameters of the switching node are presented. The parameters of the control system for various parameters of the network traffic with self-similar properties and with various random errors and distortions are studied. During the data transmission and processing in intermediate switching nodes, there are significant delays in signaling and controlling information, as a result of which the level of information security decreases, namely the criterion of information availability in critical infrastructure systems. To ensure the stable operation of the electronic communication network and control system, it's necessary to constantly monitor the parameters and state of the network and search and predict faults. Let us consider the effect of signal and control and information delays on the efficiency of searching for and determining the locations of failures, overloads, and emergency modes in communication networks. The specificity of the problem is caused by delays in the transmission of signaling and controlling information, which are random and can vary over a wide range. The problem of network conditions monitoring is solved based on differential equations with a delay, so-called deviant argument that deviates. There is no general method for solving such problems. The most effective method of qualitative analysis of such equations is the approximation of derivatives by finite differences. That is the transition from differential equations to difference equations. The purpose of the article is to develop a control system for an intelligent electronic communication network with a large amount of network equipment and random delays in signaling and controlling information. The control system must ensure the operability of the network as a complex system in the event of failures in equipment, uncontrolled changes in operating modes, and the effects of disturbances, interferences, and other adverse factors. The task of estimating the parameters and state of dynamic system with delay, which is used as a network segment model, is a retrospective identification problem. It's assumed that the segment under consideration is practically independent of other segments and is connected to them by appropriate transmission lines. Consider the problem of discretizing of a differential equation with a related argument and ensuring the stability of the solution. Miscellaneous differential equations with constant coefficient and deviating argument has the following form, as you can see on the slide. Under conditions of comparable smallness of network clock synchronization, intervals in compression with charges in its parameters and states, equation can be discretized as follows. We approximate it by finite difference equations on the form as you can see on the slide. It is shown that to maintain the stability of the control system, it's necessary to reduce the absolute value of the feedback coefficient in the control loop with an increase in signal control delays. However, the problem of finding the relationship between the feedback coefficient and the delays does not have a unique closed form solution. In addition to that, there are uncontrolled deviations in dynamic characteristic and deterioration in the quality of control. Using the discretization method of a differential equation with a delayed argument, a typical model of a network node as an object of control has been developed, which is you can see on a figure 1. A network node as a control object is a feedback system that must provide some response to variation in its state. For example, general congestion, reception congestions, and bandwidth reduction, buffer underrun, improper functioning, complete or partial failure, or etc. failures. For the correct operation of reliability management systems, the response time must be tuned very carefully. With a very short response period of the target node, the control system will receive a sequence of conflicting information signals. The system will be in a state of undamped oscillations and will not come to a stable state. On the other hand, if the response period is too long, the state mechanism will respond too slowly to be of any real benefit at all. To have the appropriate quality of the control process, you need to apply a certain method of adaptation, but the correct choice of time constants is not a trivial matter. A digital simulation of control system for the parameters of the switching node was carried out. The parameters of the control system were investigated for various network traffic parameters, in particular triple or quadruple, as known as language, video, and data traffic, with self-similar properties, and with various random errors in distortions. To ensure the global stability of the control system, the feedback coefficients were specially selected. The main results of the simulation is the dependence of query length variations on the response time of the network node compared with the delay time of data processing and delivery. As a test information signal, function X, a step function of changing the instantaneous intensity of traffic, was chosen with the additive random process superimposed on it, disturbed according to the Pareto law. The figures in the next slide will show the simulation results for two values of the relative network node response delay, L, with a full delay in data processing. Here, the function Q is a transient response of a control system with processing delays in information and controlling signals. As can be seen from figures 2 and 3, with a significant difference in the response delay of the network node and the total delay in the processing and delivery of data, there is a minimum stability margin of the control system according to the buffer overload criterion. With burst of network activity caused, for example, by the burst of self-similar traffic, the risk of buffer overload, controlling signal packet dropping, and as a result, the network management system switching to the undamped oscillation node increases. At the same time, when matching the mentioned delays, sufficient resources of control stability is provided according to the buffer overload criterion for the same statistical characteristic of a burst of network activity. It should be noted that delays in the detection and recognition of useful signals and interference of equipment failures occur not only in the description of statistical characteristic, but also in the evaluation of various time parameters of signal, the application of signal communication principles, etc. For the optimal selection of such important characteristic of control system as the current reaction time of the control object, it's necessary to constantly analyze the delays of signaling and controlling information and adjust the parameters of switching nodes for them. It's quite logical to choose the value of current reaction time of control objects close to the value of the mentioned delays. The result of digital simulation also testify to this. So you can read more about the proposed multi-stage fault finding algorithm in the materials of the article. Now to the conclusions. To ensure the functioning of electronic communication systems in the conditions of possible presence of various defects in the communication equipment, changes in operating modes, disturbed actions, interference, actions of intruders, and other adverse factors, various types of redundancy are laid in the system. Actions of intruders are laid in the system, structural, hardware, signal, information, and others. So additional hardware or computing resources designed to manage the network and to deal with congestions should be in a state of reserve and put into operation after determining the time and place of the found overload providing the necessary level of system functioning. This paper proposed an approach based on a regular monitoring of the parameters and state of network nodes, taking into account the delays in incoming information about the parameters of the state of a particular network node and the delays in the control information necessary to regulate the parameters of the network node as a control object. So errors in the estimation of the random processes parameters use as diagnostic signs to determine the state of the object lead to the fact that the fault may be not found during the first search cycle. Therefore, a multi-stage fault-finding algorithm is proposed to increase the reliability of fault detection. Reasoned expediency and features of its use. The partial implementation of the approach proposed in the work will ensure the availability of information resources, which is extremely urgent task in the modern conditions. Thank you for your attention.
Thank you, Alexander. Dear colleagues, have you any questions?
No, I have question, right?
Please.
I'm from National Aviation University, and I have a question about your systems, communication systems. In aviation, we have communication, navigation, and surveillance system, CNS system, and they are working together. But in your approach, only communication system or other systems? And where application your communication system? No, for example, in aviation.
For now, I cannot present you any application about this. It's more theoretical development of the dividing the process of traffic of service information inside the network. So it can be used in every type of communication direction. So in aviation, the same problem that the massives of the data which we're using, which you using in your networks are too many. So to decrease the service information inside the network, we propose to divide the node that will work with service information and prevent the failures, which provides the next step of the overload of buffer, for example, or for the increasing the numbers of equations with which we need to count to make the process of information
no, thank you. I understood.
Inside the network.
This is important questions for aviation too. Last year was year of integrated system, communication, navigation, and surveillance, and together integrated system. Last year in ICAO was. Thank you. Very interesting approach for improving the communication system.
Thank you for your feedback.
Any questions, colleagues?
I have a question.
Please.
So you consider your communication node as a system under control. What are the control parameters and control functions for the node? Thank you.
I'm very sorry, but I cannot hear the question properly.
Alexander Lvovich, maybe louder.
Maybe a little bit louder, or yes.
Okay, so you
don't hear.
Node. Can you hear me now?
Very badly.
I don't know why. Okay, wait. Just something.
You may ask your question in our faculty.
I think now it's gonna be better.
Yes.
So you consider your communication node as a system under some sort of control. What are the control parameters for the system? And what's the control function that you implement? Thank you.
The main parameters that we using in this approach is delays of signaling and controlling information using the feedback coefficient, which accounting to the buffer overload. So we're predicting the number of the equations that we need to count, and to prevent the buffer overload. So we reducing the numbers of the equations by transferring them from differential to differences equation, and using the parameters of the delays of control and signal informations as a major parameters. So they are the identifiers of the state of node, and the node which is divided from the from the major system as the as a side service system. So the node, this side node will used by independent system, which is counting only the service information that we're using inside the network. So it slightly increases the number of the node that we're using in a network in general, but it highly effective to decrease the number of counting massives that we have in a large perspective networks. So if we're using for example, networks with a self-similar traffic as a sensor networks, with a lot of traffic, with the problem of parameter drifting. So while the battery is lowing, if we cannot change these sensors, we have to ensure the availability of the information through in other ways. So one of the ways is decreasing the number of counting data. We can use the nodes of service information and in this way decrease the measurement nodes not overflow, but I forgot the term in English.
In Ukrainian, please.
Напругу, зняти напругу. Tension from the nodes that using as a measurement components of the network. I hope I answered to your question.
I think you can either engage more resources at your node if you have spare capacity, or you have to somehow reroute the traffic if your node is not able to meet the demands, no? Do you?
Yes, of course.
Do you implement the second one?
The moment of the transferring the direction of the signal and controlling information in the network is one of the things that can develop the traffic, the marshrutization of the traffic, and improve the insurance of the information in the network, of course. But in this case, we're taking care about the amount of information in general, not just the marshrutization or switching the information between the nodes. So question of marshrutization, it's little bit on the side when we're speaking about the quantity of the information. And it's built more on a network, one of the solution of network efficiency. But still, of course, it should be counted in a perspective.
I think the most promising is just to change the routine, shall we say, and reroute trouble spots in the network, and that's the best way. So in the future research, if you take into account this approach, it would be good. Thank you.
Thank you. We will.
Thank you very much, dear colleagues. Your questions, answers are very interesting, your discussion, but we must go ahead. Any questions, dear colleagues? No? Then we have 20 minutes coffee break, and we should start our work at 11:50. Please, coffee break.
Thank you very much.
And the effect of associate with the fading the channel is to add to the call cyclic prefix to the base structure of the OFDM signal. The signal resampling procedure is also used. In addition, there should be no the inverse fast Fourier transform and the fast Fourier transform are the main function they accompany respectively the process of modulation and demodulation on the transmitting and receiving side of the channel. Thus, in the order and implementation endpoint fast Fourier transform in the receiver part is necessary to have accurate sample of the transmitted signal with a duration corresponding to an OFDM symbol. That is time synchronization needed to fix time starting point of the each OFDM symbol. Slide number 3 present the formulated problem of the presented study and outlines the direction for the solution. An important task of effective implementation of OFDM is to determine the change in probability of occurrence of beta error in the such system due to distortion associated with the impact they maintaining the orthogonality of individual subcarriers. The main factor of such distortion can be considered the fast fading effect, jitter, frequency offset, nonlinear distortion, etc. The main action of all these factors direct ultimately to occurrence of crosstalk between subcarriers or OFDM signal. The consequence of the formation of interference in the package or OFDM subcarriers is the impossibility of the ensuring optimal signal reception due to the departure from the condition of subcarrier orthogonality. The specificity of the present study is based on the fact that despite the significant advantage of the OFDM concept, in the case possible deep fading, combining the transmission of such signal has a selective effect of some subcarriers by suppressing them and the other on the contrary amplifying them. This pattern ultimately leads to an increase the average signal to noise ratio. Selective fading effect occur in the OFDM channel. When the described phenomena occur, the issues the reliable data identification, channel estimation, and the issues the synchronization come therefore. The work presented mechanisms that counteract such effect over the channel, which is based on the use of coding methods with the forward error correction. Thus, the novelty of the study focused on the finding conditions for the improving the noise immunity of the signal reception in the OFDM channel under condition of selective fading the multi-path propagation by applying error correction code method. The condition of modeling the noise immunity of OFDM channel are discussed in slide number 4. On figure number 1, present the developed Simulink model, a communication system for investigations. The main system setting the software simulation are presented on slide number 4. We used the CAM modulation, choose the sampling rate, cyclic prefix length, fast Fourier transform, duration, signal duration. In general case, such a signal formed by significant set of subcarriers that form a common frequency bond. We emphasize that instead of subcarriers, a number of orthogonal subcarriers are used, while by combining subcarriers into generalized data stream and a possible significantly increase the information transfer rate. The concept of signal condition is based on method of individual modulation of the subcarrier, in the case general formalized signal model of the output of the CAM modulation presented the following expression number 1. The specificity of the transmitting part or channel based on the use of the inverse fast Fourier transform procedure with the apply the symbol in this sequence at the output of inverse fast Fourier transform, we obtain the total format orthogonal sinusoid with the can be presented by expression number 2. Simulation of synchronization condition in the OFDM channel presents slide at number 5. We presented this slide that shows the importance of ensuring synchronization condition in OFDM information channel under real interference condition. The inverse fast Fourier transform, the fast Fourier transform procedure play a key role in the case to take into account the inter-symbol interference and inter-channel interference phenomena in the analytical description of synchronization condition. We denote the error due to the action of inter-symbol interference psi as psi and due to the action inter-channel interference is mu. Then the mathematical model, the process of OFDM signal receiving side of channel under condition of frequency shift symbol under influence interference at the present at the following expression number 3, expression number 4. Possible cases of the time shift of OFDM symbol are presented interference in the reception signal are shown figure number 3. On slide number 6, present the visual natural distortion and the OFDM signal processing using fast Fourier transform windowing. In particular, this slide shows the illustration of the influence effect inter-symbol interference for the each subcarriers OFDM signal. See figure number 4. On figure number 5, an illustration occurring the phenomenon inter-symbol interference between OFDM symbol which a cyclic prefix length shorter than the maximum delay in the multi-path channel. Figure number 6 illustration the influence of the choice of the starting point of the fast Fourier transform window on the occurrence inter-symbol in interchannel interference of OFDM subcarriers. On slide number 7, based on the result of mathematical model, and we show the consequence and distortion of the channel from the OFDM to the result of influence interchannel interference on the signal phase in the time domain. On figure number 9, represent constellation diagram. Position A in the absence in the interchannel interference, position B the presence of interchannel interference, the form a constellation diagram, the case effect corresponding to the third is the C, and for the case in position D, see figure number 9. To determine the effect of such distortion on the noise immunity of OFDM channel, we perform mathematical model on slide 8. Show the result of OFDM noise immunity estimate. We estimated the probability of occurrence of the beta error depending on the level of signal to noise ratio in the OFDM channel when the change in the signal type, see figure number 10, the oversampling factor, figure number 11, and the fast Fourier transform size, what is applied, figure number 12. Mutual operation for the transformation of the fast Fourier transform in the inverse fast Fourier transform in relation to vector component x and y are given by following expression number 5, expression number 6. From the obtained dependence experimental conclusion that forms that increase the fast Fourier transform length from the 1512 to 2048 points requires increase in the signal to noise ratio about the 6 decibels, increase in the length of fast Fourier transform, expand the bandwidth of communication system, and requires the use of error correction code to improve energy performance. The result of studying the impulse performance, the properties of the channel, I illustrated the figure number 13, formula number 7, the formation content of the channel impulse response appropriately obtaining detailed information about the current state of the channel. This turn useful the channel equalization step of receiver. Figure number 14, experimental dependencies of the estimation, the influence of cyclic prefix length of the noise immunity in presenter, the minimization of influence, interchannel interference due to choice of the duration of cyclic prefix creates the duration of the multi-part delay. A study was cyclic prefix different 1/2, 1/4, 1/8, 1/16 of the duration of OFDM symbol, the result of figure number 14 representing the length of cyclic prefix 1/4 of the symbol duration, the transmission rate drop by 25%, but then increase the length of the signal multi-part delay. The optimal cyclic prefix duration 1/16 of the symbol duration, which reduced the data rate by 6%. The simulation was carried out according to a condition of signal formation based on 128 subcarriers to construct the multiplexer data. The sampling rate of the 1.92 megahertz was used, the choice of cyclic prefix duration, and the level of 9 samples. Figure number 15 shows the spectral pattern at the receiver input. Description of the coding schema presented on slide number 9. In accordance with the formulated task, we analyze system with OFDM or the evaluated channel coding, improve the noise immunity of system with a digital modulation. In parallel, the work compares the efficiency of signal coding construction based on turbo code as a part of concatenated coding, the context of their application OFDM in OFDM. In figure number 16 shows the block diagram of turbo encoding containing 2 convolutional recursive encoder on the length equal 5 implements the feedback shift register. The design feature compared the classical of a convolutional code. Each code block of turbo code triggered additionally for L-1 bits at the end of the frame of the information sequences. After encoding the last bit in the frames, the leftmost adders each component encoded take 2 copies of the same feedback bit, set their outputs to 0. After the L-1 bit for a memory cell filled with a 0, but as the time and encoder continues to output to 0 encoded symbol. In this encoder design, the encoding rate 1/3, 1/4, 1/6 without the punching procedure. A punching was used the coding rate 1/2. From the frame length 1632, 16,384 bits, different interleaver were made, including pseudo-random regular operating according to permutation rule with the records of the result. In a lookup table, the diagram that show figure number 16 synchronization element are provided. In the particular, the synchronization mark serves to control stage on the input buffer, control the content of the buffer, which respects the original buffer multiplexer in the fixed frame synchronization pointer. In component encoder fix moment expansion of code block. It should be noted that encoding process is necessarily accompanied by the signal time delay. Timing and the entire information block of L bits must be read before the next block is submitted for encoding. Next, a construction of the channel coding basic component turbo code, the Reed-Solomon code is proposed. Therefore, the synthesizing the structure of turbo encoder will be placed the following accent. The implementation of the turbo encoder has peculiarities. In the particular, the information block must be buffer rather than the certain order during the encoding process. Such buffering the absent the convolutional code and the buffer size is compatible the interleaver side the Reed-Solomon code. Thus, the turbo encoder generally plays the concatenated design based on the convolutional code and the Reed-Solomon code, and not alternative the convolutional encoder in the above concatenated design. However, a combination of the such code will improve the efficiency of concatenated coding. In figure number 18, we also display the nuances of the decoder circuits. The design the decoder formed by the 2 decoders, organized according to principle soft in, soft output seesaw mode, one of each stream formed by a single convolutional recursive block. On figure number 18, the practical scheme of the turbo decoder. the number of algorithm functioning of the turbo decoders, minimum decoder scheme error probability, seesaw model provides the maximum a posteriori decoding algorithm. In general, the following decoding algorithm can be used: the logarithmic map, max log, maximum a posteriori, and the solo viterbi decoding algorithm. Mathematically, for systematic code, the solved decoding can be presented as the following: number 8. A scheme for the investigated the transmission system with the OFDM tuba code-based channel code, and represents slide number 10. On figure number 19 shows a scheme for investigated the transmission system with OFDM and tuba code-based channel. As follows the diagram, the input frames of tuba code are grounded. Each block packet forms the OFDM frame, which begins with synchronization symbol followed with the reference symbol. The first symbol will be used to determine the frame start time and estimate the frequency of set, and the second will be used to estimate the frequency response of the channel. That is assured the ensuring synchronization condition is very important. Let's touch in detail. Synchronization of tuba code block achieved through the use of synchronization markers, see figure number 10. In the case and the length of tuba code and the synchronization marker is inversely proportional to nominal coding rate. Therefore, the synchronization efficiency depends on the encoding rate, the receiving side, the info communication channel, the synchronization marker identified by the features of the structure. It should be known that each of the decoder, the composite decoders, see figure number 20, cannot always correctly identify the effective size of synchronization marker, which is very important. Indeed, then the decoder, the long tuba code, the decoder of a constituents decoder must be clearly identify the boundaries of the decoder block, including taking into account the determinate, the interleaved data and the decoder structure. Therefore, the synchronization marker usually includes a channel symbol domain that defines the framing method. The bit mapper block calculates the probability of a receiver channel using the formulas number 9, 10, and 11. On slide 11, we presented investigation of the noise immunity OFDM system with a channel coding. On figure number 21 show the scheme for studying the transmission system OFDM channel and coding based on the concatenated coding, dependencies of bit error ratio, and the corrective ability of Reed-Solomon code makes it possible establish Reed-Solomon code has the performance 255, 173. As a follow from the diagram figure number 21, the input frames of the tuba code are grounded. Each block packet form a OFDM frame, which described above in the work. In the figure number 22, dependencies of initial position, output, and bit in the coder block and the input position for the different type of interlevel. Evaluation, performance.
Excuse me, dear colleagues, excuse me, 1 minute left.
Okay. The evaluation. Okay, the evaluation performance system represented figure number 12. The performance of system was evaluated conducting the series numerical simulation experiment and the various configuration of coding decoding scheme and the IWGN channel. For research construct 100 frames, the size were used containing 20 packages programmatically. The model had setting according to the null structure information transmitted on the channel. The next slide, it is conclusion technique for improving the noise immunity of the system with efficiency coding. The describe recommendation of the use of forward error correction coding methods are given. The scientific problem increases the noise immunity of signal reception of the channel under conditions of selective fading and multi-path propagation is solved by applying error correction code method. A coding scheme with second OFDM channel based on concatenated coded signal coding construction is proposed. Based on the result of study, there was determined that with the increased length of the code segments and the number of the coding iteration, the productivity of the process proposed signal codec construction increases almost 2 decibels. However, performance by 3.9 decibels when changing the waveform, the moving higher order modulation signal codec construction. When deploying network-based OFDM, necessary to optimize the oscillation signal codec construction, turn the coding rate and the computational complexity with ultimately make it possible find a compromise in the performance indicators. Next poster, thank you for attention. In Ukrainian, дякую за увагу.
Thank you very much. Dear colleagues, ask your questions. No questions. Very wonderful and very expressive report, dear Yuli.
Thank you. Thank you very much.
Thank you. Dear colleagues, next presentation, Alexey Bычkov, Katerina Merkulova, Елизавета Жабska, exploring conditions of image samples formation for path identification information technology. Please.
Thank you. Dear colleagues, for your attention, present the research of Taras Shevchenko National University of Kiev on the subject of exploring conditions of image samples formation for person identification information technology. As far as face recognition technologies are increasingly being used in sensitive areas where any mistake can be crucial, it is important to explore information technologies of face identification to reduce the possibility of failure occurrence before they will be widely used in any purposes. In our previous studies, there was introduced and explored a novel information technology for face recognition and identification based on local texture descriptors. It relies on an algorithm based on HAR features, Gabor wavelet transform, local binary patterns in one-dimensional space, and histogram-oriented gradients. These methods are employed for tasks of face localizing image processing, extraction of feature vectors, respectively. More elaborate explanation of the algorithm's methods is provided on the slide. The purpose of this research is to explore the conditions of image sample formation to which the algorithm is applied, to investigate the algorithm performance in condition which applies to images captured in constrained and unconstrained conditions, as well as the ways of improving the resulting identification accuracy rates. Therefore, it was decided to conduct the experiments on different databases that contains images captured under different conditions of fixation. The initial set of experiments was focused on determining the efficiency of the algorithm after it applies to original face images containing in the databases. On the slide, the obtained results are presented. It was established that on some images, the algorithm is not capable to localize face region. Moreover, the research algorithm performed more efficiently during its appliance on the images captured in semi-constrained or constrained conditions, regarding the background, lighting, subject's head position, camera position in relation to the subject, and other physical settings. Also, images are uniform within the single database. Considering these problems, it was decided to perform the next set of experiments. The etalon and test images samples were reformed by extracting images in which the face region is not recognizable. As for the image captured under unconstrained conditions, the etalon image sample was expanded with images with recognizable face features of the same individuals. The results of experiments are presented on the slide. As can be seen, the extraction of images with non-recognizable face regions allowed to increase the identification accuracy rate of the algorithm on 7.545%. Also, the expansion of etalon image samples for databases that contain images captured in unconstrained conditions has led to the improvement of the efficiency of the algorithm of 15% for the CFP and HDB databases. Obtained results are varying in the wide range of identification accuracy rates. Such variability may be caused by the fact that the selected databases contain images with different file format and resolution. Therefore, it was decided to conduct the experiments in order to determine whether it's possible to improve the algorithm performance by eliminating image properties, variability, and by that reduce the range of algorithm performance results. To perform the experiments on format converted images, the JPG, PNG, and BMP formats were selected. Results of experiments on format converted images are presented on the slide. It can be concluded that the format conversion was effective only after appliance of the algorithm to the images samples from database of faces. Accuracy rates increased on 5% on JPG converted images. Also, variation of results is observed in case of LVW database. Accuracy rate has decreased on 5% in case of expanded echelon image sample. Even such minor changes indicate that the format conversion in individual cases can be crucial for success of identification process. The next set of experiments was conducted with resolution conversion. The values of resolution were chosen with regard to those images on which the previous experiments showed the highest rates of identification accuracy. Analyzing the results presented on the screen, the identification accuracy rates of the algorithm changed in the following way for the samples of face images from databases. Database of faces increased on 5-10%, Ferret decreased on 5-35%, SC face decreased on 10-30%, SFP increased on 5-15% on initial and 5-10% on expanded samples. In tiny face increased on 10-15% on initial and 25-35% on expanded samples. LFW decreased on 10-20% on initial samples and increased on 25% on expanded sample. HDB increased on 10-20% on initial sample and decreased on 5-10% on expanded samples. In conclusion, during the research, it was found that the performance of the algorithm is affected by the presence in the echelon and test samples of images in which it is difficult to localize face region due to such conditions of image capturing, extreme angle of rotation of subject's head, excessive lighting, and so on. Also, algorithm performance can be reduced during its appliance on samples of image captured under unconstrained conditions regarding the background, lighting, head position, camera position in relation to the subject, and other physical settings. After extracting from the echelon and test samples of images with unrecognizable face features, and expanding the echelon samples of images from databases that were formed under unconstrained conditions, the accuracy identification rate of the algorithm was improved on 7.45%. Also, it was established that format of images in individual cases affects the efficiency on 5%. The conversion of resolution has also affected the algorithm performance. The results for resolution converted images were increased on 35%. The highest identification accuracy rate, which is 95%, was obtained on image sample of initial images from SCFace database and on image sample after reforming of the echelon image sample by extracting images with unrecognizable face region. That is all. Thank you for attention.
Thank you. Dear colleagues, please, questions. No questions. Okay, dear colleagues, it will be lunch now. We'll meet at parallel sessions at 2 p.m. Maybe you have any questions to me? No? Lunch and parallel sessions at 2 p.m.